Okay, so today I'm teaching John, you've met John, about vector determination and addition, the 3D version. This is our drawing. We have two vectors, F1 and F2, and we're going to use these equations right here to find a resulting vector. Sounds fun?
Yeah.
Yeah, okay. You don't have to lie. No, it's fun. Don't worry. So okay, we'll start with the first one. So the first one we can use this equation, but the second one we have to be a lot more creative. Do you know these Greek letters? Alpha, beta, gamma?
Yep.
You've heard of them?
Mm-hmm.
Okay. So alpha, in this sense, is the angle from the x line to the vector. Beta is the y, from the y to the vector, and gamma is from the z to the vector. And so obviously it gives us those three angles, so we can just plug them in and find what we need. And this f is the magnitude, which is 500. That also is given to us. So I'm going to factor that out so I can write it all. But I'm going to copy this here. Okay, John. So I plugged in all these, that number, and that number into the equation. And that's the magnitude, that's what that absolute value sign of f is, whatever. And when you simplify it down, that's what you're going to get in the I hat direction, the j hat direction, the k hat direction of f1. That's what that is in vector notation. And so when we do f2, we have to be a lot more creative because it doesn't give us alpha, beta, and gamma. So to break it down, we are going to F2. We're gonna have to the x component of F2 is this right here, this line from the origin to about right there. That's how far it moves in the x direction. I'm sorry, that's the y component. The x component is this part right here. That's how far it moves in the negative x direction. So since it's negative, that's an easy negative right there. But what we know is that red line. And so if we take 300 times the cosine of 60, we're going to get this line right here, which is the hypotenuse of this triangle on the bottom. And so if you took the sine of 45 times that hypotenuse, you're going to get your x component. So does that make sense?
Yes.
You sure?
I understand the gist of it.
And that's your I hat. That's this line, the magnitude of that component. And so your y hat is the same thing, or your j hat, I'm sorry, is your same thing, except we need this line instead of that line. So we're going to do cosine instead of sine. And it's in the positive direction, so we don't have to have that negative. And fun fact, cosine and sine of 45 is the same thing. So even if you didn't know that, you would have gotten the right answer. But and so in the j hat direction is a lot easier because it's just this line right here. So if you take the sine of 60 times 300, you'll get the j hat, the positive j hat direction. Sine 60. Okay. So then the magnitude of F2, the vector notation of F2. Okay, so what I did there, I just simplified each of these terms down to this. And knowing the two vectors broken down, we can just add them together to make our resulting vector notation. And so what we're going to be doing here is this. So in order to find the resulting vector, all you need to do is break these two down and then add up the x and y components. So this right here, that 250 added to that is going to be the x component of the resulting vector, which is ended up as 143.933. And then the same goes for the y and the z directions. And so this is the vector notation of our resulting vector if we added F1 and F2 together. But it's direction and magnitude, but it's kind of hard to read. So a better way to do it is to take the square root of all of them squared and find the actual magnitude. So what I did here was take the square root of all of them squared to find the real force. And so like you see how this F1 is 500 newtons and F2 is 300 newtons. Add them together, the resulting force would be that. But we don't know the direction. And that's this. We use these three equations to find the direction. And so I'm going to plug and chug again. Okay, so each of these equations broken down. This angle, alpha, is going to equal the inverse cosine of the x component of a resulting vector divided by its magnitude, total magnitude. Beta is the same thing, except the numerator in here is the y component, and gamma is the same thing, except the numerator in here is the z component. So this is the math for it, and these are the answers that you would get. 72.62 degrees, 17.43 degrees, and 88.83 degrees. And so what these mean, you can see it with F1. This is alpha, right, at 60. The resulting vector is going to be about 72 degrees instead of 60. The beta is this one right here. Instead of 45 with F1, it's going to be 17 with the resulting vector, and then 88 with gamma instead of 120. So these are, this is the direction it's going, the resulting vector, and this is the magnitude of that resulting vector when you add F1 and F2. Good?